Hi everyone. So I realized that the audio was not recording during the last lecture, so I'm going to go ahead and just do a voiceover PowerPoint for this lecture that then I'll post to YouTube. So the audio is going to be a little different from what I did during the lecture, but it'll cover all the same content, so no problem about that. So last time we talked about why we need an environmental policy. And it had to do with this idea that the market is not properly valuing the environment. And this is due to a few different things. We talked about the tragedy of the commons and Garrett Hardin's and Eleanor Ostrom's approaches to solving that. We talked about externalities when there are costs related to production or consumption or goods or services that are paid or impacted by or impact a third party that isn't related in that that isn't part of that transaction. Pardon me. And we also talked about the free rider problem when an entity receives a benefit without paying for it. And so I just mentioned that in the paper mill example we looked at in class, that the paper mill in this case was a free rider because they were getting the clean water without having to pay for it. So as a result of that, the clean water wasn't valued, and so it was not taken care of. So I shared an actual example of a paper mill. This is some research that we did in Nepal. And so this is a paper mill that opened up in the 1990s in southern Nepal. This is a picture of the water outlet of the paper mill near the city of Narangat. This is the Narayani River. It flows into Chitwan National Park from here. This is a picture of myself and my colleague when we were there in 2015 collecting some data from this particular site. So we're looking at fish populations. And so here's a graph showing the results of what we found. These are data related to the number of species of fishes on the y-axis. And then on the x-axis you can see the year and the season. And we collected data at two sites. The dotted line was downstream from the paper mill, and the solid line was upstream from the paper mill. And those lines are pretty close until we get to the 90s after the paper mill was constructed, and all of a sudden we see that solid line much higher than the dashed line, and that means that there were more fish species upstream from that paper mill than downstream. So suggesting that that paper mill was in fact having an impact on the number of fish species. So I just wanted to let you know I'm not making up the fact that paper mills have negative impacts on fish species. Okay, so if we look at a history of environmental policy in the United States, it'll give us an idea on how we got to be where we are now. Now again, this is where we have to step back and acknowledge that this part of our nation's history was fraught with inequity, particularly as it relates to race, and so that the ability of people to move around our country varied greatly based on which race they belonged to. And so people of African descent did not have the chance to move around the country. However, those that did began moving west during this time period to move away from these densely populated cities. And as they did, they found these incredibly rich resources, these forests with the tree in the picture on the right. You can only imagine when people saw trees of this size, of course, the notion of resources ever running out was foreign to them. So our early environmental policy, there really wasn't any. The idea was that resources were unlimited, and that the environment's ability to store waste as well was pretty unlimited. The picture on the lower left there is a mining operation in Alaska, and it just devastated the landscape. But folks didn't think that it was going to have any negative impacts. Then as we moved into the late 1800s all the way into the mid-20th century, we started becoming aware of some of these environmental impacts. So Yellowstone National Park, the picture on your right there, was created in the 1870s It is, by most accounts, the first national park in the world. And the idea was to set aside land so that it wouldn't be impacted by deforestation and these kinds of processes, which had been happening on the East Coast. There were some sort of rudimentary attempts to protect the water, including a piece of legislation passed to keep rivers clean, but really all this piece of legislation said was that you couldn't pollute rivers to the point where ships could no longer travel down them, because in some rivers in the east so much trash was getting thrown into them that these ships weren't able to move around. So at this time we started to see some efforts to protect the environment, but really nothing systematic as we moved into the mid-20th century. All right, and then a couple things happened in the 20th century that really started to show us about the environmental impacts that we as a species were starting to have. So one of these was the burning of the Cuyahoga River, the picture on the left. This river had caught fire a couple times, but it caught fire once when there was a reporter from Time magazine there, and so all of a sudden it became a national story. This idea being that if our rivers are so polluted that they're catching on fire, then we're starting to have a serious environmental impact. And Kendall actually pointed out in class the other day that this was the anniversary of the Cuyahoga River catching on fire, and in fact it caught on fire again recently due to a spill of some fuel, I think it was. So the Cuyahoga River still has its problems. The picture there on your right is of Rachel Carson. She was a scientific writer and a scientist for the government, and she wrote an environmental column in a few different magazines, and so people started writing to her with some of these stories of environmental degradation, particularly the effects of pesticides. So Carson wrote a book called Silent Spring, which some of y'all may have read, and this is one of the books that really set the tone for environmental conservation in the U.S. Now, she unfortunately passed away from cancer and didn't see the impacts of her book, but it had a major sort of mind-changing effect on the national psyche. This is an excerpt from the book. Carson writes, "Man's attitude toward nature is today critically important simply because we've now acquired a fateful power to alter and destroy nature. But man is a part of nature, and his war against nature is inevitably a war against himself. We're challenged as mankind has never been challenged before to prove our maturity and our mastery, not of nature, but of ourselves." So we can see now this acknowledgement of this idea that humans are able to have these incredible impacts on the environment, more than we'd never ever been aware of before, and that we were going to have to exercise self-control to start to moderate those effects. So today, if we look at surveys of public opinion, folks value safe and clean environment. This has been shown consistently over time in surveys of public opinion. So after Carson's Silent Spring was published, it led to a lot of environmental legislation to protect our resources. And there's just a few that I'd like you to take note of. The first was the Clean Air Act in 1963. This Clean Air Act was mandated at the national level and required states and counties to protect the air and monitor certain pollutants. And if it didn't meet the national standards, then there was funding to help meet those standards. The National Environmental Policy Act came along in 1970, and we'll talk more about that in just a second. The Endangered Species Act in 1973 was very important, and we'll talk more about that later in class. And then the Clean Water Act in 1977 did for water what the Clean Air Act did for the air. It created standards of pollution, essentially pollution limits, and if they were crossed, then there were fines and pretty serious penalties for violators. So let's just chat a little bit more about the National Environmental Policy Act. One of the big things that it did was it required an environmental impact statement, and that mandated that any federal action that might impact the environment had to essentially write out what all the potential environmental impacts of that were. And this connected to all sorts of pieces of legislation. They had to talk about how it would relate to the Clean Air Act, the Clean Water Act, Endangered Species Act. How is this project going to impact the water, the air, rare species? And this also holds true for any projects using federal funding. So this all of a sudden required studies when things like roads were constructed to really get at how this would impact the environment. And so a lot was learned through the development of these environmental impact statements. 1970 was also the time when the Environmental Protection Agency was created, and that consolidated all of the management and regulatory authority for the environment under a single agency. So the Environmental Protection Agency does all these things. It's a lot. They carry out research to see what sort of chemicals are hazards. They monitor the environmental quality to see what sort of pollution things are happening. They set and enforce standards for these pollution levels. And then in cases where the pollution levels are higher than they should be, they assist states in meeting those goals. And then they have an education component as well. But the Environmental Protection Agency really tries to work with folks rather than shutting down violators. And so because of that, they kind of have a bad rap. This little, what would you call this, a meme, I guess, says the EPA keeping polluters in business since 1970. Because the idea is if you come in and you shut down a factory that's polluting immediately, there's going to be job loss, it's going to have an economic impact. So what the EPA tries to do is to work with those companies, those factories that are polluting, and get them to decrease their pollution over time rather than shutting them down all at once. But that doesn't suit folks that think that there should be stricter, that polluters should be dealt with more harshly. So the EPA has a hard time kind of walking this middle ground. So there's sort of two approaches we can take to environmental policy. We can take a command and control approach, or an approach that uses economic policy tools to try and allow the market to essentially value the environment on its own. So a command and control approach is where there are national standards that are set, and any violation of those standards or limits results in severe punishment for violators. So it's very top-down, very mandated at the federal level, and then must be followed at the local level. So the way that we dealt with a lot of most of our first pieces of environmental legislation were of this type. So like the Clean Air Act has certain pollution levels for different chemicals that can't be exceeded, and then if they are exceeded, there's pretty severe penalties for that. Well, another approach is to try to create a market environment that values the environment. So we've talked a little bit about some of the problems of this earlier, but just some examples of ways to try and take those externalities and put them back into the cost of goods and services, to fix the free rider problem, to deal with the tragedy of the commons. So a couple ways are through tax breaks and subsidies. Tax breaks are changes to tax codes that allow folks to pay less tax if they engage in desirable activities. So, for instance, in the state of North Carolina, there are tax breaks, for instance, for installing photovoltaic solar panels on your home. And so you can write off, it used to be up to $10,000 in taxes. I don't know what it is now. But so that's a way that the government can make it more advantageous to do something that values the environment. Then subsidies are giveaways of cash or resources to encourage a particular activity. Interestingly enough, again, looking at solar panels, for quite a while, solar panels made in China were much cheaper than solar panels made in the US. And so to encourage our solar panel industry, the federal government subsidized solar panels, because essentially solar panels were being subsidized by China. And so in the US, we subsidized solar panel producers so that their products could compete. So anyway, that's just a way of trying to encourage a particular activity, in this case, development of solar panels. We could also create what's called a cap and trade system. So if you imagine that we're trying to reduce pollution of nitrogen oxides, for instance, this is a picture down in the lower right of trees that have been damaged by acid rain. What we could do is we could say, all right, the government is going to allow a fixed amount of nitrogen oxide pollution for the whole year, and that you as a company have to have a permit to be able to pollute. So the government creates a market in permits, essentially a market to pollute, if that makes sense. And then once that limit is set, then industries can trade permits, permits for different kinds of pollution. They can trade permits for one kind of pollution, another kind of pollution, or they can even sell those permits. And the way this usually happens is through auction. So the government will say, we're going to allow, I don't know, 100 megatons of nitrogen oxide pollution, right? And we're going to sell, 1,000 permits that will cover that. So let's start the bidding for those permits. So companies then will bid on those permits, and they'll sort of set the price. Now, interestingly enough, organizations like the Sierra Club and folks like that can also buy these permits, and they, of course, don't pollute, and so that essentially retires the permit and reduces the amount of pollution overall. So thinking about the advantages and disadvantages of this permitting approach, that this is a cheaper way to meet these pollution reduction goals. And the other is that it provides an economic incentive to reduce pollution. So if I have to pay for each increment of pollution that I produce, then there's an incentive for me to do research to develop ways to produce my product by polluting less. It'll cut down on my cost of production, right? So again, trying to let the market value, in this case, innovation that protects the environment. But there's some potential disadvantages as well. The first is that larger companies might be able to afford to pay more for these permits. And so if they were to go in and say purchase all the permits for a given type of pollution in an industry, then potentially they could drive the small companies out of the market. And then when there's less competition, they would not have to worry about, in the case of pollution, they wouldn't have to worry about getting outbid for those permits because they would have outcompeted these smaller companies. The other problem is that if all these permits are bought by companies in a certain location, then we might have very high localized pollution, even though we've set a limit for the whole country. So the idea is that over time you decrease the amount of permits that are sold, and so you reduce pollution over time. All right. Well, as I mentioned in class, this is a time where we shift gears a little bit in class. We've talked about some of these broad environmental issues, and now we're going to discuss ecosystem ecology in particular, talking about chemistry, energy, and ecosystems. And I cover these topics a little differently than the book does, so I really recommend that you listen to the way I cover them in lecture first, and then go to the textbook. So the interesting thing about biology is that it's hierarchical. We can pick a question that interests us and look at it on many different levels. So we could take the question of, for instance, PCB pollution, and we could talk about it on a global level as we did in our case study, in the biosphere, the Earth. We could break it down to the landscape level, the community and ecosystem level, our population level. And on down, we look at it as an individual organism level, right? Like how are salmon affected by PCBs? And we could go all the way down to the molecular level, right? How do PCBs interact with the other chemicals in the fish? But we're going to be studying ecology. That's really the area of biology we'll be focused on. So ecology in general is focused on the levels of organization above the individual organism. So populations, communities and ecosystems, landscapes, biosphere, that's the level of organization we're mostly going to be talking about. So we just went through and defined a couple of terms, a group of individuals of the same species, and of course I have fish examples. This is our population. Now, if we add in the population of all the different species that live and interact with each other in a given time and place, this is our community. And it's important that we constrain this by talking about the species that live and interact with each other, because that's going to determine how evolution works, and it's going to determine the way that these species interact and how they affect one another. Okay, well then if we take the community and add in its physical environment, in this coral reef for instance, we've added in the water, we've added in the sand, we've added in all these different things, then that's our ecosystem. So we can talk about, for instance, a coral reef ecosystem where we've got the living population of all the species in addition to the non-living physical environment. All right, so one of the first things we have to understand about ecosystems is that energy is needed for anything to happen. And so we can ask the question, how does energy move throughout the ecosystem? And the first model we'll talk about is what's called the food chain. And so this is a linear flow of energy. So we have a terrestrial food chain on the left and an aquatic one on the right. And in both of those we have organisms that are capturing the sunlight, turning it into carbohydrates, and the energy is moving up the food chain. Now, each level in this food chain, each link in this food chain is what's called a trophic level. And so trophic just refers to food. So here we'd say we have 4 trophic levels, and we can classify those trophic levels different ways. The first is, how high is it on that food chain? So we can talk about our producers, our primary producers. They're making the food themselves. They're eaten by our primary consumers, who are then eaten by secondary consumers, tertiary consumers, on up. So on land, our primary producers are the plants. Primary consumers might be caterpillars. Those are eaten by secondary consumers, the lizards. Then these lizards are going to be eaten by snakes, our tertiary consumers. And then there's similar things on the aquatic side. The other thing we can do is we can classify it based on how it acquires its energy. So autotrophs, auto meaning self, troph again referring to food. So autotrophs literally feed themselves. Then everything else are heterotrophs. They have to get their food from someplace else. And they can do it several different ways. We can have herbivores, which feed on plants, carnivores that feed on animals, and then similarly to our consumers, we can have secondary carnivores, tertiary carnivores, and so on. So that was a pretty quick run through. I figured you'd have a chance to go back to these to these different slides in the YouTube video and pause it as you needed to, go back as you needed to. So I hope you find that useful, and I'll be posting this to YouTube tonight, and I'll see you all in class tomorrow. And if you have any questions about the material in this lecture, feel free to drop by my office hours, shoot me an email, or you can even come up to me after class. So hope you all are doing well, and I'll talk to you soon.